Hey everybody, welcome. Um, this week we're going to be focusing on a we're going to be focusing on some motion related things, specifically with setting up a type of mechanical mechanism called a cam and follower. This type of mechanical mechanism is fairly common today, and is also was very extremely common before we got to essentially programmable control of machines, where we could uh, computerized or CNC control of machines. We had multiple camshafts and cam and follower systems were used to essentially do the programming of a lot of different types of machinery, printing presses, um, certain types of like screw making, like automated screw making machines. They would use cam and follower systems to basically create motion profiles in a purely mechanical way. And um, you can see here, this model is a little messed up. Let's see if I can fix that. Back up here. There we go. You can see here that we have a shaft that has some features on it that are interacting with a roller that's attached to essentially like a pusher plate. And as this shaft rotates, we create a linear motion at each one of those plate locations at a specific time. And uh, each of these plates has the same motion profile because the profile um, of these cam lobes are all the same. And so being able to set up a system like this really kind of comes into play with doing some more advanced work with the different types of joints and relating joint movements to one another. This leads into the other topic that we're going to talk about today, which is motion links, where we kind of work with proportionality between two different joints. But before we get into motion links, I want to talk about um, a another type of component relationship that is not technically a joint, but is ultimately what enables us to create the motion relationship that we see in front of us right now. And that is, if we come down here under assemble, that is the tangent relationship. It's right under rigid group. And this is actually much closer to a geometric constraint in its behavior in the sketch menu than it is an actual joint. But for the tangent relationship to work properly in this circumstance, we have to work with joints in a way where we kind of relate them to each other, or we use them um, in a coordinated fashion to control essentially the axes of movements that are allowed in the machine to accurately create like this motion simulation that we're seeing. So uh, this is the model that you guys will be creating in this week's assignment. And I'm not going to have a dedicated tutorial on modeling every component in here. Um, there will be drawings made available. The geometry here that we're working with is really simple, and the it doesn't require anything beyond the regular tools that we've been using thus far in the quarter. So I'm this tutorial is going to focus solely on how do we set up this relationship that we see displayed right now, and then we're going to cover that in this video, and then there'll be a second video where we talk about explicit motion links. That way, this is compartmentalized a little bit, and hopefully these videos are not 40 minutes long. So, but this is kind of a preview of very nearly the final state of our assignment for this week. So let's talk about how do we go about setting this relationship up. Over here, I have some, and I'm just going to be using these components that I've created already to demonstrate how this works and how we go about doing, like, setting up these mechanical relationships. We have a couple components here. We have our cam lobe, we have our camshaft, we have our follower, and then we have our follower guide and our camshaft guide. And the follower guide and the camshaft guide are going to be, are actually going to play like the kind of pivotal role in how we set up in setting up the relationships that we need to have between components for this to work. So if we look at our if we look at these components, the first thing that we're going to do is we're going to create a joint between our cam lobe and our camshaft. So I'm going to select that center snap point and that center snap point there. And here we actually want this relationship to be rigid. And then we're going to click OK. And so this cam lobe should be dead center in front of this shaft right now. The drawings for this week will dictate like the spacing for these cams, for the cam lobes on the main camshaft. In this final assembly, you'll have those spacings called out. So we have a rigid relationship between our camshaft and our camshaft and the cam lobe itself. So they're effectively one piece. The next thing we want to do is that we want to create the motion, this relative motion here, where the shaft rotates along a single axis. So we're going to use the revolute constraint here, and we're going to use that between this component here, which is our camshaft guide. And so we're going to create a a new joint. We're going to go to motion. We're going to select revolute, and we're going to come back to our position tab. We'll select this front snap point and the snap points here. And then we're actually going to offset this slightly for demonstration purposes here in just a moment. And then the next thing that we're going to do is we're actually going to ground our camshaft guide. And with our camshaft guide grounded, at this point, we should be able to rotate our cam like so. The next thing that we're going to do is we're going to create the motion joint between our follower guide and the follower itself. So here, this is going to be, if we come back and look at our main assembly here, these followers move in a strictly linear fashion. They just move up and down. We want to recreate that through the use of a slider joint. So if we come back here, we're going to create, we're going to go down to assemble, joint. We're going to come down to slider, hit position. we are going to select this component. And then we are going to select our follower guide. And we're going to hit OK. Now, you can see that this is happening at an angle, right? We're located, or the angle that this is at is kind of odd. If we, with our regular components, when we're setting these up, we also need to account for the angle of approach of the follower when we're setting up our model. In our assignment this week, that is handled by the cam follower plate here. You can see that this follower plate is serving two functions. It is locating the camshaft, so this component is grounded. You can see that by the icon in the by the component symbol. And we have slider relationships between each of the followers and the cam plate. The cam follower plate, excuse me. And we have a revolute joint relationship between the camshaft and the follower plate as well. And so we're using a single component in this example that controls our slider relationship and our revolute relationship, but it also controls for orientation of our followers here. In my example, this orientation is uncontrolled, and I'm doing this deliberately because I want to demonstrate something. I want to demonstrate something about the tangency relationship when we use it. So if we have our tangents, we activate our tangency relationship. It asks for components. Now there's some things that we need to pay attention to when we do this. We want to select the actual surface that we want to interact with. And then we want to take our other component that we want to trace that surface of and click that. And you can see that all it does, and we can hit OK here. All it's doing is that it is forcing these two surfaces, these two profiles, to essentially be tangent to each other. So now if I rotate this, let me get back to home position here. There we go. If I rotate this, you can see that this is not behaving in the way that we would like, right? And so we have to force or control the angle of approach that our follower comes in at. So you can see that like we have this ability to kind of like move and reorient our follower if we are not accounting for controlling the angle of approach. This component here, the cam follower plate, handles this for us because of the way that it is oriented. It has these two arms that come here and they orient to the camshaft. And then we have slider joints that exist between this component. Let's activate our joints so we can see them. You can see that we have slider joints that exist between the follower plate and the actual followers. So, and then there's a tangent relationship between each of the rollers and each of the cam lobes. So here, to avoid this situation, we need to control the angle of approach of our cam follower. So the way that we're going to do that is we are going to also, in this circumstance, we are going to ground our follower guide here. So let's go down to follower guide, and we will also ground the follower guide. We'll capture our position. And now you can see that as we rotate, we have essentially constrained the angle of approach. We have constrained the manner in which the follower can move with a slider joint. We have constrained the location of the camshaft through the combination of the revolute joint that exists between the camshaft and the camshaft guide, in combination with also grounding the camshaft guide. So what this does now, you'll see here that we're still not 100% perfect in terms of our angle of approach, right? And this is why, when we're looking at and when you guys are looking at the drawings for this, the reason that doesn't happen on these components is because the slider joints, thank you, these slider joints exist between even though they exist between the follower and the cam follower plate, this component and these components, what's happening is that the slider relationship is actually located at these individual cutouts. So if I remove those, so you can see that if we look down on this, that the cams are located directly below these square cutouts or square through holes through the cam follower plate. And that is giving us our orientation, that constrains our orientation and our position of the follower and the angle. So here, if we wanted to solve this problem here, we could create we could set it up so that our guide is perpendicular to our camshaft at 90 degrees. So if I believe if we just use the move tool here and we select our follower guide, let's try this. Oh, our follower is grounded right now, so we will unground this. That's why we couldn't do that. We'll do move copy, and we're going to interesting. So what we can see here is that tangent relationship is interfering with our ability to orient this. This is good to see. I didn't run into this problem when I was testing this before I started recording, but nonetheless, this is important to understand about the tangent relationship. So what we're going to do is we're going to come back to the tangent relationship temporarily, and we are going to suppress that feature for the time being. And now we are going to come back here to our follower guide. We're going to select components. There we go. And we're going to look at this from the right here. And we're going to make that 30. 33. Yep. That looks straight up and down. And I'm just eyeballing this for right now. Then we're going to move this here. We're going to ground reground this component. Oh. Just ground that here. Capture our current position. And then we will reactivate our tangency relationship. Unsuppress that. If we look at this in profile, we're not perfectly lined up, but again, that's taken up by our that's accounted for in the physical design or the mechanical design of the follower plate. So keep that in mind as you guys are doing this week's assignment. But you can see now that we have this relationship where the tip of the follower is always in contact with the tangency, or is always tangent to the profile of the cam. And you can see that we still have some alignment issues. And setting this up in a more deliberate way, we would spatially constrain like where this is located relative to our cam follower, like we're doing over here. But the point here is like what I want you guys to focus on is like the order of operations that we had to go through. So I'm going to essentially actually roll. We're going to roll back to capture that position. Yep. We're going to roll back here where we should not have. Yeah, we don't have any joints really. And we're going to kind of reassemble this really quickly, go through it one more time. So everybody has a chance to kind of look at this one more time. So again, we need to set up some relationships between our okay, I'm back. Sorry if there's a continuity jump. Ran into some technical issues. So really quickly, what I want to do is just cover this one more time and reiterate how these different joints work in relationship to each other to make this cam follower mechanism function. So we have our camshaft, and we want the camshaft and the cam lobes to essentially be treated as one body. So again, we're going to grab our joints. We're going to select our rigid joint. And we are going to make a rigid joint relationship between the cam lobe and the camshaft itself. And then we know that we want this camshaft to be able to rotate in a known point in space. So we are going to, again, create another joint that exists between our camshaft guide, and that's going to be a revolute joint. We'll offset this a little bit so we have something to grab when we're animating this. And then, so now we're at a position where we need to essentially ground our components, the camshaft guide, so that we lock this in position, like so. Then we need to create a slider joint. um, between our follower and the follower guide. So we're going to come back to joint, motion, slider. Grab that component and that component. Click OK. And then we need to ground our follower guide. And now we should have this motion here. And then what we're going to do is we're going to create our tangency relationship. Select our first component and our second component. Oh, we have more info because there are conflicts with the assembly the existing relationships. Interesting. Why have we run into this? There we go. I selected the wrong part of the wrong part of our follower rod. We had to select the dome there. So now we have our tangency relationship set up. If we look at this from the right, and you can see that we have a cam and follower relationship set up. There's one more thing that I want to point out. If we go back and we look at our assembly here, earlier you might have noticed that, and that happened just again, that as we were rotating this follower dropped through our component, and it's not, and the model is no longer kind of like behaving how it should. The way that we solve this is with contact sets. So if we back up here and we go down to our, we're going to enable contact sets. We're going to create here, this contact set was already created. I'm actually going to delete that contact set really quickly, and I'm going to demo going through this. So we have our contact sets. We're going to do new contact set. We're going to select our bodies and our components. So the easy way to do this is whenever we're setting up contact sets like this, it's always good to select like the fewest amount of bodies to interact with as possible. Now that we have this contact set created, if we begin this rotation, you can see like the animation is not as smooth, but no matter how quickly oh, it's still happening, which is surprising. I wonder if that is surprising. Let's try that again really quickly. We're going to delete that. We're going to do assemble, new contact set. We're going to select our bodies. There was one other thing that I forgot to select here. So we have a contact set that exists between the rollers and the cam lobes. We need one more contact set. So we're going to do the other contact set that we need is going to be between these components and this component here. Now, as we do this, oh, it's still, I'm surprised this is still happening. I might have to do some more research on, or I will have to do some more research on why this is still happening. But let's back up here. In theory, this might be a glitch in Fusion 360 right now, but in theory, we should be prevented from having these contact sets misbehave at this point, because we have a contact set that exists between here and here that theoretically should be constraining how the roller and the cam lobe should not be able to pass through each other, and then the follower with its plate should not be able to pass through our our follower plate here. So this follower should not be able to pass through this surface. I'm not sure why that is still allowing that. I will have to do more research, but in theory, it should be solving that problem. But you'll notice that, like, as I added these contact sets, the smoothness of this animation went down pretty dramatically, and that is because calculating contact sets takes up a lot of CPU power, or it's more processing intensive to work with contact sets. So if you are trying to simulate motion and those types of things, having contact sets or having the minimal amount of contact sets necessary can save you processing and resources time. Suppress both of those. With those off, you can see that this moves much smoother now. Which brings us to the very last thing that I wanted to discuss, and we're coming up on 30 minutes for this video, so we'll go over this really quickly. It can be, I've been like manually running this for this entire tutorial. And if you're just trying to visualize the relationship for yourself or somebody else that you're sharing the file with, this can be kind of annoying to do. And so you can use this tool called Motion Study. And if we look at the tooltip here, it says perform kinematic motion analysis based on joints. Select the joints to participate and then specify the points and values of the motion. So what this does is that it lets us essentially somewhat automate our the process of actuating the different joints. So to interact with this tool, we're going to select the Revolute joint here. And you can see that this line pops up. If I start selecting other joints, we start getting different options here in this menu. Depending on using the motion study tool here, we don't need to select all of these different joints to be involved in the study. We only really need, in this case, the Revolute joint here, because if we close this out real quickly, this joint essentially drives all of these different relationships by the rotation of the shaft. So if we do a motion study, we come down to assemble at the very bottom, motion study, right there. And we just select that Revolute joint. Now we can say we have a motion study that has 0 to 100 steps. If we click on that line, we can enter a value. We can say this should be 360. You can see that this changes. And if we hit animate now, it rotates 360 degrees. Now you'll see that it still has artifacts that show up. But the point here is, like, the point of the tool is that it's a way for us to kind of animate how the mechanism is supposed to work without us like manually working it, like using the mouse to manipulate components in the design space. down here we have 3 different modes. We have single actuation. We have oscillating back and forth between the 2 extremes. And then we also have looping, which just moves in one direction over and over again. We can add points to along this path. So at the end, we needed to be at 360 degrees. If we say that for whatever reason, this needs to be 180 at this point, you can see that the profile here is changing. And this is very similar. You can think of this as something very similar to a step displacement diagram. And so you can change like the speed of actuation of the joint at different moments in time along this profile. So if we made this, if we made this, for example, 2 degrees here. So from here to here, it's going to move 2 degrees. From here to here, it's going to move 180 degrees. And then from here to here, it's going to move 360 degrees. It's going to move the remaining 360 degrees. And you can see that like the rotation slows down and speeds up at different points along this profile. So this can be a really powerful tool for taking a look at how your mechanism is going to work with the joints, with all of the joints that you've set up. Once you're done, you can just click OK. It doesn't save the motion study. The motion study is just a tool that you open up. You configure it kind of like as one shot, and then you go. So I think that covers everything for this video in terms of setting up the relationship for the cam follower mechanism, doing the motion study, how to constrain, or the types of things we need to account for when we're working with multiple joints. So I think we'll call it here, and then in the next video we'll talk about motion links, which is another way to relate joints to one another.